Namaskaram everyone, welcome back to the 15th episode of our Master Unreal series, and in this episode we are going to build the inventory UI widget which has been inspired from Resident Evil 4 inventory. We will have the primary case, we will have the discard case, and we will have space for the character as well. So we are going to create it and plug it into our game. So let's just get started. Last time we created inventory system folder and we had this BPC blueprint component inventory manager. So I'm going to go inside the inventory system and I'll create a blueprint class, call it actor. I will name it B underscore inventory case. So this is the case in which we are going to keep our weapons. Now this inventory case, why it is an actor is because this case will be placed in the world when you will press I to toggle the inventory, and then you will be able to see the weapons that will be placed inside this viewport. So that is the overall idea why we have this inventory case as a actor component and not as a blueprint component of the character or something else. Cool. All right. So I have organized this a bit. In the event begin play, first we create the pickup widget, then we create the pickup message widget. Then every tick we check for items, and if the items are present, we show the pickup message, that is press E to pick up. And then we have another event that will run when you press E, and then once you press E you will get the widget that will ask you to press yes or no and then handle your choice with this on send pickup choice event. Okay, so these are the 4 things that we have done so far in the pickup item event that we did in the last video. First I want to check if there is any items nearby. So I'll check if the nearby items length is greater than 0, then only I would like to find and then check and then pick. Okay, so if there are no items, then there is no point of running this find nearby item. This is what we missed last time. And now we are going to spawn this inventory case in the world as soon as this component is mounted. Now I'm going to create another event graph in the BPC inventory manager just to keep things organized. So case graph, or let's call it weapon case graph. And in this, I'm going to create a custom event that is spawn inventory case. So as soon as this component mounts, we will call this event in the event graph, main event graph. So event begin play will fire this. So I'll call that here spawn inventory case. Here we will call the spawn actor from class, and the actor is B inventory case. And let's split this so that you get these default values and then you can hit compile. And once the actor is spawned, we will hide it in the game. So what do I mean by that is we are not gonna continuously, render all the weapons again and again back and forth. Like I press I, then you spawn, then you destroy, spawn and destroy. That will consume resources. So to optimize it, we are going to hide this inventory case object in the world if you do not press I. But if you press I, then it will be visible, and that's it. And then I'm going to promote this to a variable and I'm going to call it case actor. And now I'm going to hide this actor. We just are going to make it invisible in the world so that you don't see it. And if you press, then you will just see the widget. Okay, so I'm going to use something called as set is hidden in game. And you can pass your actor and you can set it to true. Once this is done, you can save and compile. In the inventory case, we are going to create a function that is toggle case visibility. So this is going to show and hide the case whenever user press I. And now we need the widget. So let's first go for widget, and here I will create inventory system. I'll move this pickup UI here, and here I will create another widget blueprint and I'll name it user widget. I'll select user widget and then WBP underscore inventory. So this is going to show our inventory. I'll save it, and here in the event begin play, I'm going to create widget. The class would be inventory widget, and the value I'll store it in a variable. So WBP underscore inventory UI. Once we have this, we want to press keys and inputs so that you can select and interact with the widget. So for that, we have to tell this widget who owns this particular component. So we need to provide the player controller here. So get player controller. So the 0th one is the one we want. Once this is done, go to toggle case visibility. So first I'm going to add a sequence node and I'm going to create a variable that will keep track is the inventory hidden. Okay, and how do we determine that is by checking this the instance. So is in viewport. So if it is not in viewport, then that means inventory is hidden. All right, so once we have this, now we are going to check the inventory is hidden or not. So if inventory is hidden, that means we have to show it. So I'll use add to viewport, and this would be the case here. And if it is not hidden, then we have to remove this widget. So remove from parent. We are also going to pause the game when the inventory is open, right? So I'll search for set game paused. So if the inventory is not hidden, then pause it. Now after this is done, I'll return the node. So I'll say is open. So if the game is paused, that means it is open. If game is not paused, then it means it is closed. So that's how you manage the values. Okay, now I'm going to create an input action for this. I'm going to go inside input actions and let's duplicate this crutch again, IA underscore. Let's keep it inventory and then save it. Go back in the IMC default, add a new key mapping, select the inventory, and I'm going to reserve this by I. So this is I, and this save. Go to your BPC inventory manager under third person, blueprints, third person character. And let's create a graph here as well, that is inventory graph. Now I'm going to place this inventory action here. But before we implement this, I think we need the function to toggle the inventory. So I'll create a function here that says toggle inventory. And this is going to call the function from case actor, toggle case visibility. And then we are going to return it. And if it is open, then return the same and then hit compile. Now, if you go back to your BP third person character, you can bring out inventory manager, search for toggle inventory, and whenever it is pressed, it will be opened and closed. Cool, we are done. We forgot one more thing here, is to hide and unhide the actor that is basically carrying your weapons. So search for set actor is hidden and then plug this here. So whatever the value is, we are going to plug this. Okay, but there's one catch, that is this inventory toggle should trigger even when the game is paused. So here, just one small correction. This return would be here. If it is in viewport, then obviously we have to hide it, but if it is not in viewport, then we will not hide it. So the direct output can be used, but for branch node, we have to use the opposite because we are still checking. So I'm going to go inside the widgets in the inventory system under WPB inventory. I'm going to add the canvas, drag it out. I'm going to create another widget, name it WBP grid case. So this is what is going to hold the grid lines. Your inventory layout can have a lot of things, not just the case full of weapons. You will have menus to switch between weapons, treasures, and all that we had in RE4. So we are going to consider that. So this is specifically for showing the grid line so that you can place your weapons. So double click on it, save it, add a canvas panel here as well. Now if you go back, you will find your widget in the user created. You have grid case. Just drag it inside the WBP panel. Once you have that, select this, choose the anchor's bottom, go for 0000 and give it a shape of 1300 by 840, and the alignment would be 0.6 and 1, and the position Y would be -114.4. Do not change this, please. This is calculated with lot of hours and efforts. Now, once you are all set, just save it and compile it. So this is your grid case, and here there will be your character. So we will go into that later. And let's also add an image that is the background. I'll go for full size in the anchors, and I'm going to drag it above. And in the image, I can choose this one. These images are again present on Discord. Just download it from there. So save it, compile it. So first we need a border inside the canvas. I'll just go in the border, drag it inside, and this is our grid case. So I'll just go full scale, and it will be fully transparent, 0 as of now, and make this variable, name it grid case. Save it. Go in the graph, you will find your variable present. Now the maximum rows, maximum columns, give them the type integer. Then the case rows, case columns. Why are these two? Because you can upgrade your inventory size as you pass the levels. So we need to keep this count, but the maximum possible count is the max rows and max column. And this cannot be changed no matter what you do. This has to be fixed because that's how I formulated all the calculations. So I will show you if you run out of space or if you have too much space, I'll tell you how to handle that. But these values have to be constant. You cannot change them. So the maximum rows that you can have is 12. So I'll compile first, and in the max rows, just set 12. And in the max columns, you can set it to 25. Once this is done, compile and save. And now we are going to create a function that is to initialize. Let me make the capital I. So this initialized will accept case rows and case columns from you. So case rows, case columns. Let's rename them to row count and column count. Okay. Once you have this, you are also going to need the unit size. That is one box of the grid. What is the size of that? So I'm going to use vector 2D, set it here. And this is going to be again coming from here. Let's rename it to box size. Now we need to call this function. So this will be done by this WBP inventory. So I will search for event on initialized. Then we are going to call this grid case. And in the designer, we can give it a better name. Let's call it WBP underscore grid case. Save. Compile, go to grid case, go to graph, and here you can find the initialize function that you created. Now this needs a row and column count. So this is what you are going to receive here as well. So I'll just say rows and columns. And I'm going to change their type to integer. So rows, columns, and we need the box size. That is a vector 2D. Okay, now we need to expose them on spawn so that you can provide the values when you are spawning this widget. So in the rows, I'll make it instance editable, expose on spawn, and do the same for box size as well. Okay, all set, compile, go to your B inventory case and refresh this node. You'll find the values. Create a folder in the content, call it utilities. So under this, create a folder called structures. This will store all the structures for us. Here I will create one structure, name it s underscore integer 2d. So this is basically going to hold two values, one x and another one is y, and it would be of type integer. So let's create a variable case size s integer 2d. Now once you do that, bring it out, split it, x goes here, y goes here. And in the case size, we can also write a description, rows, x, columns. And the box size would be 65. And the return value will be plugged here. Save and compile. Go back to grid case. Now in this, we are going to get this grid case. We are going to slot as canvas slot, and now we will set its size based on the case size you have got. So this is the unit size. multiply and split it. So in the utilities, I'm going to create a library called blueprint function library. I'll call it BP underscore generic functions. These functions will be available all over the actors, components, and files. So I'm going to go inside it, float vector to integer vector. And we are just going to return it, create a vector, change the type to vector 2D, split it in the output, just call result, change this to s integer 2D, split this one as well, pass x to x, y to y. Trust me, when we are going to write the logic of path calculation and all that, this is going to save us a lot of space. Create another one, that is convert to divac to fvac. That is nothing but integer vector to float vector. And I'm going to return the same thing here. So let's just speed this up. Now we are all set. You can save all and compile this. Now if you go back to your grid case, what you can do, and let's create another variable called max case size. Now since we are having this function, I'll remove this and I'll go for s integer 2D, and the max case size would be compile and expand it. X would be rows, so 12 rows, 25 columns. Okay, save and compile, bring it here, convert to divac to fvac, and make these functions pure because they are not modifying anything. All right, save all, compile, and now you will see it's a pure function. You don't need to connect the execution pins, and pass this value to our in size. So this would be the size. Now we need to compute the grid lines. Now we need to draw vertical and horizontal lines. So I'll make a sequence, and now I'm going to draw the vertical lines first. So let's first bring the max case size out, split this pin, use a for loop. We'll start from 0 and goes columns. So for this, I'm going to use a branch node, and I'm going to bring the case columns here, check for greater than equal to, and pass the index here. And we are going to check one more thing. That is the discard case. So when you grab the weapon, you want discard case grid to be visible, but the space between the primary and the discard space will be present because of the customizable size that you can give in the case. So for that, I need to check whether the for loop has reached to the index of the discard case. So I'll check if index is greater than 18. So if it is greater than 18, then we would like to go and compute the vertical lines. Other than that, we are just going to stick to the case columns limit. And in the local variables, let's keep track of last x. Why last x is because when it comes to mathematical graph or grid, the horizontal is x-axis and vertical is y-axis. But Unreal Engine takes it completely opposite. If you are going in x direction, that means you are going in y direction. But if you are going in y direction, Unreal takes it, you are going in x direction. So don't get confused. I would say change it to float because this can vary. I'm going to use multiply, and then I'm going to bring the unit size. I'm going to split it. I'm going to plug this x here and this one here. And then we are going to go for a branch node again. Now this is the part where we decide whether this is a primary case line or a discard case line. So I'll go for discard case lines. So for this, I'm going to create a structure, call it s underscore line. Now s underscore line has a source, that is the vector 2D, and there is something called as end. Once this is done, save, go back to grid case. Now if you go in discard case line, you will find the s line here. Change it to array because there are going to be multiple lines. Go for primary case lines. Okay, so if the index is greater than 18, that means it is a discard case area. So we are going to push this line in the discard case array. So let's bring it here, add, and if it is not, then that means you are still in primary case area. Because if you are in middle of these two, then this will not allow you to go ahead. Now we need to calculate the value. So I'll go for make s line here, and I'm going to plug this here and this one here, and I'm going to split this as well. So the last x will go here and here. Now to get y, so I would like to go for select int, and then I'm going to multiply this by the unit size, and I'm going to plug this x here, connect this to y. So again, the same query. If it's a discard case, then we are going to follow the discard limit, and if it's a primary case, then we are going to follow the limit that is set by the user. So if it's a discard case, I would like to go for max size. I'm going to go for x here, and if it is not, then I'm going to go for the case rows that has been provided by the user. Now this is the logic of vertical lines, and now the horizontal lines. So for this, I'm going to go for for loop again, and I'm going to duplicate the max size, that is rows this times. So for all the rows, we are going to draw the horizontal lines. Go for a sequence node and create another variable, local variable, of course, last y, and change it to float. And the type would be single. Once you have this, plug it here. Now for the value, multiply node. First it would be index, then it will be unit size. Once the last y is set, we are going to check whether the iterator is less than the case rows, that is the limit which user has set. Actually it should be less than equal to, and plug this here. So if it is less than case rows, that means it is the primary case grid line. So I'm going to go for primary case and add, connect this pin to this. Once you have that, go for make s line, connect this one to this one. Do the same, bring last y here, split these two pins, and it will go on y and y. Now we need the end x, search for multiply. The unit size y will go here, and the case columns will go here, and you're gonna pass this to end x. So this is for the horizontal line of primary case. Now we have to draw the discard case horizontal lines. Now no matter what case size user plays, but discard case will be always available to up its max limit. So I'll go for add, connect this pin to here, and I'm going to split these two pins, split again, and bring the last y, push it here. Here's a catch, the start x would be 19, so multiply, it would be 19, because the discard case will start at the 19th index. Remember, we check greater than 18. That means the 19th index will be the first that will qualify that situation. So that's why I said 19. And this would be multiply as well. So I'll go for max case size, split, max case columns, and the unit size. Split, x would go here, y would go here. Okay, we are all set. This is the entire logic of horizontal lines, so just name it. Okay, so I've beautified the graph a bit, save and compile. Now you have all the coordinates. This will be done only once. So if I go to initialize, I can call this compute grid lines. This will store the grid lines in these variables. Once this is done, we are going to go in the override and go for OnPaint. This is the function under this user interface painting category that will run every frame, so your grid lines will be visible every frame. So let's break it, go for a sequence node. So first we are going to draw the primary case lines. So I'll go for each loop, bring the primary case lines array, pass it here, and here I will call draw line, and we are going to create another function that will be calculate position of line. So we are going to pass src, which is vector 2D again, and the input would be a line. So line, search for s line, split it, you got the source and the end, add it, pass it to the source, add it and pass it to the end. Now what do we have, and now what do we have to add is get the local top left, plug it here, and local top left of what we want to get the cache geometry of the grid case. Cool, save and compile. Okay, I think we compiled too early. First, let's make this function pure. Save, go back in OnPaint and bring this function here. Pass your element that is nothing but line. Source would be here, end would be here. Context would be this. So search for get context. Once this is done drawing the primary case, we are going to duplicate this for discard case. So I'll just right click and replace the variable with discard case lines. We also have to select this calculate position of line and we have to mark it as constant and then compile. So I'll just add another pin and just return it. In the WBP inventory, let's add a delay of 0 seconds just to make sure this execute afterwards. You can always tweak the size in the inventory case, and I can put like 12 rows and 16 columns. Play, press I. You can see this is the dead zone area that I was referencing to. Okay, so that's it for this video. I hope you enjoyed it, and the next video we are going to set up some basic colors and the case pointer and movement. Till then, stay tuned, join the Discord community. Do let me know if you have any doubts and questions in the comments, and subscribe to the channel, and I'll see you in the next episode.